Okay, particle mass 0.3 kilograms, moving a smooth horizontal surface. That speed, horizontal impulse, magnitude of that. Okay, I'll find the greatest and least speeds. Well, so initially it's going like so. That's 0.8 meters per second. And the particle has got mass 0.3 kilograms. And to me, greatest speed is if the impulse goes like that, and the least possible speed will be if the impulse goes like that. And so for the first part, I know that impulse equals gain in momentum. So that'll be mv minus mu. And I want to move it around, so I want to get mv equals add mu to both sides, and v equals I plus mu. And now we can do what it is. So for maximum, we'll get mv equals I, which is 0.6, plus the mass, which is 0.3, times by 0.8. And that means that mv will equal 0.84. That's not what I wanted. I want the greatest speed. And so therefore v will equal 0.84 over the mass 0.3, and that is 2.8 meters per second. For the min speed, we need to do mv equals minus 0.6 plus 0.3 times 0.8, and that means that mv will be minus 0.36, and so v will be minus 0.36 over the mass, which is 0.3, and that equals minus 1.2 meters per second. Therefore, min speed is 1.2 meters per second, because speed can't be negative. Instead, I'll do this next bit in red. After the impulse, speed of p after the impulse is 2.5, and so we're going to get here, hopefully we can squeeze it in here. I'm still going to be using the formula. I'm going to be using an impulse momentum triangle. mv equals I plus mu. So I need to have my initial momentum, which remember is mass times the velocity. So that will be 0.3 times 0.8, which is 0.24. And then the impulse is still 0.6, but I need to work out what the final velocity is. It says the final velocity is 2.5, so I've got 0.3, the mass, times by 2.5, and that equals 0.75. So it's going to be quite a lot longer than this, so it's going to be like so. And that will be mv, and that equals 0.75, and that's my impulse there, 0.6. And now we can do it. I need to find that angle there. Well, actually, the angle I want to find, this is my impulse. I want to find this angle here. So I'm going to work out what x is first, and then take it away from 180 to find out the angle the impulse makes with the initial momentum. And so I get a squared equals b squared plus c squared minus 2bc cos a. So that means 2bc cos a equals b squared plus c squared minus a squared. Divide both sides by 2bc. Gives us that. And now I can put it in there. Cos a equals b squared, so that's 0.24 squared plus 0.6 squared minus 0.75 squared, all over 2 times b, 0.24, times c, 0.6, and that equals minus 0.503125. Therefore, that should be x, or x equals cos to minus 1 of that, 120.2069 degrees, and therefore required angle is 180 minus 120.2069, which equals 59.793034 degrees. Obviously, give it to three significant figures. And that's question 1 done.